For those of you who have registered but cannot be here, we'll make this recording of this Ask the Author on Data-Driven Transport Infrastructure Maintenance available on our YouTube channel. Towards the end, I will pop up a short poll to see if you like the session or not. That helps us to kind of improve what we're doing. But I want to reduce the time that I'm speaking and hand over to Olaf Merk, who's the lead author of Data-Driven Transport Infrastructure Maintenance, to take us through the findings. And then it'll be your turn to ask questions. The way to do that is to use the Q&A icon at the bottom of your screen. Type your questions in to that field. You can start doing that right from the beginning. They're all listed on my screen, and I will then repeat them so everyone can hear them, and Olaf will answer. So without further ado, as they say, here's Olaf Merk on Data-Driven Transport Infrastructure Maintenance. Olaf.
Yes, many thanks, Michael, and welcome to you all. I am indeed happy to provide you with our main findings of a recent report on data-driven transport infrastructure maintenance. And the idea of this presentation is basically to guide you through that report. I have a little presentation for that. I'll start with well, what is the aim and the relevance of this report. Just try to get my presentation going. There we go. I'll say something about maintenance. What is the challenge related to that? Then a few words about what are really those data-driven approaches. Then I'll give a few applications in selected transport sectors, what has been happening. I'll give an assessment of the merits of these approaches. And finally, I'll finish my presentation with the policy recommendations in the report. And then, of course, I'd be happy to answer any questions that you have on this. So, what is the relevance of this topic? Why did we do this report? Well, first of all, because maintenance, of course, is an essential, sometimes invisible, but inevitable part of transport policies. And transport maintenance is likely to become more important because a lot of the infrastructure is aging, because there is climate change it's taken into account. So this is a subject that is going to be more relevant. And of course, the question then is, are there ways to get better value for money if you talk about the maintenance of transport infrastructure? So that's basically the aim of the report, assessing the potential of these data-driven approaches to improve the transport infrastructure maintenance. So what we did is a kind of an assessment of maintenance strategies that exist and the exploration of the potential in different types of transport infrastructure, and then the policy implications of that. And like all ITF reports, we also have policy recommendations on how to deal with these data-driven approaches of transport infrastructure maintenance. I should say this report builds on a workshop that we had with members of our corporate partnership board. That is the body within the ITF in which we engage with a lot of different companies within and outside of the transport sector. And we also were helped by written contributions by two professors from the Luleå University of Technology. Now, if we talk about maintenance, and the maintenance of the transport sector in particular, one can see there are basically two sorts of maintenance strategies. One is the corrective maintenance. So that would be actually correcting the damages or the failures when they take place. So it is kind of reactive. It is actually maintaining infrastructure when it's already too late, you could say. And the second main strategy is preventive. So that is trying to reduce the probability of failure and also trying to avoid, of course, the deviations of the service levels that the public expects. So a lot of these are planned in advance and they are performed when the time is convenient. Within those preventive strategies, you could say there are two sorts of sub-strategy, if you want. One is the predetermined preventive strategy, so that is according to timeline that is established by a predetermined rule. So that could be according to a time, so for example, once in 6 months, or that could be according to usage. So that could be if a certain amount of vehicles has passed on whatever, on a bridge, or if a certain amount of total tonnage has passed the bridge or whatever. So there are different ways to do that. And then there's another preventive strategy which is called the condition-based strategy, which is more depending on the actual degradation over time. So this is not according to a predetermined rule. It is actually trying to see what is the state of the infrastructure, and according to that condition, maintain, do something or not. And this is where our data-driven approaches enter in the story, because this is done with data collected via different monitoring techniques. Now, if you do this often, so if you repeat the analysis, it makes it possible to actually assess the health of an infrastructure asset at this time. So it's what you call nowcasting, but also use that information to forecast the future state and also the future maintenance needs of that infrastructure asset. So that could be called predictive maintenance. So these are different maintenance challenges that are used by infrastructure managers in a lot of different countries. Of course, when we talk about data-driven approaches, we talk mostly about the condition-based preventive maintenance. Data-driven approaches are basically based on three different pillars, if you want. So it's about information, so getting the right information. It's about analyzing that information, and then it's also about putting that information, placing that information in the relevant context so that you can actually take actions. So that's what this figure is basically trying to show. There can be a lot of different data on the conditions of infrastructure, the data on what has actually been maintained in the past, business data, and that can all be put together in information models that can then be used to be analyzed, which is what we call knowledge models, and then be put into context and also used for action. So that would be the context models. So these are, in essence, of course, this is a very generic picture, but these are in essence the approaches that are used and that are helped, of course, by different technologies that have been developed over time. And one could say that the data-driven approaches have really gained momentum thanks to 4 different technologies: digital technologies, the increase of computing power, better sensors and sensor technology, and finally, artificial intelligence. Now, if you look at how it's applied in transport sectors, you could say, of course, the picture is mixed. It depends on country. It also depends on transport mode. Here we'll give you 2 examples. I'll give you an example on the rail sector and on the road sector. When you look at the rail sector, you see that the data can come from several sources. Of course, the traditional method is using actually manual inspections, the track inspection cars. And then the new technologies would, for example, be drone-based track inspection. And more and more artificial intelligence is also used via the track degradation model. So that's modeling of some of the data that are collected. Well, the implementation of artificial intelligence in railway maintenance is, of course, dependent on information that is available, that is accessible, and that is, of course, sometimes a challenge. But there is work done to create data sharing platforms in which a lot of different stakeholders can provide the data that can help to develop this artificial intelligence in railway infrastructure maintenance. When it comes to analytics, what we found is that there is still a lack of specific data analytics tools. So there are systems and algorithms that can predict the wearing of real infrastructure, but these seem for the moment to be limited to lab conditions, so not yet applicable to real life. But of course, it will be a question of time before that can actually be used. When it comes to the road sector, of course, also there, the data traditionally come from manual inspections, but there are also various new methods that are can also be automated. I put a few terms here, not to really explain all this, but the vision-based methods, radar scanning, ground penetration radars, and dual light methods. This is all in the report, but this is just to give you an overview of the different sorts of technologies that are being used. And that makes it possible to, for example, to detect the cracks in roads automatically through pavement image processing and machine learning. So there is quite some advancement that has been made in there. A general remark on all these, let's say, newer technologies is that most of them are accurate or seem to be effective, but most of them are also pretty costly. Which means that the use for the moment has been fairly limited, and also the coverage of let's say the road networks by these applications is fairly limited. There are also other methods that could be used, so there are quite a lot of pilots also trying to use the regular smartphones to collect data on road conditions. And this has actually, let's say, the opposite characteristic. So it is cheap. So it has that advantage, but it delivers lower quality data than the other techniques that I talked about. Now, looking at all these different data approaches and technologies, what could you say are the merits of all this? Certainly, it could have advantages. So the potential advantages of data-driven approaches are that it could increase the quality of fact-based decisions, because in essence, machine learning and also artificial intelligence can process much larger data sets than you could actually process manually. So it could improve decisions if it is well done. It could also increase the transparency in decision-making, because it could make more data available than currently exist. So in a way, it could also democratize the decision-making process. It could also help to enhance collaboration between different stakeholders in different transport modes, and particularly when it comes to transport infrastructure maintenance, because all these data-driven approaches, they could promote a culture of collaboration. Collaboration is needed to get the data, and then of course, when you have the data, you also have already more collaboration. That is also good in itself. And finally, it could reduce the bias of decision makers if they use these kind of artificial intelligence methods. That could also be at the same time one of the disadvantages, one of the setbacks, if of course the algorithm or the model is made with a bias, via the bias of the modeler, then of course the output of that model could also be biased. Other setbacks could be low quality data. So that is related. If you have low quality data, of course, probably the outcome of your model will also be of low quality. So that is a challenge for decision makers. Another possible setback is if decision makers no longer understand the model, so they blindly trust the model and are not actually able to question certain assumptions in the model to improve that, because that could simply mean that there is a bias in the model that continues to exist and that isn't corrected. And finally, there could be a setback or a challenge related to limited transition of domain knowledge. That is, of course, a lot of the knowledge is context specific, and that is, of course, something that humans are very capable of, that machine learning in itself cannot do if it isn't also feeded with that kind of context specificity. So that is also something to take into account. So there are merits to these data-driven approaches, and there's huge potential, but of course that depends on certain conditions. Well, that brings me then to my last slide, that is the policy recommendations. Basically 3 generic recommendations here. So the first is, well, to scale up and also speed up the deployment of these data-driven approaches. We think there is a lot of potential, and there have been quite a lot of pilots, but actually it would make sense to accelerate the rollout of these data-driven approaches. Of course, if the technology is ready and if it is feasible to apply. In some other areas, one might need to be a little bit more cautious, but also there we think there should be test and pilot projects to try to advance on what are still specific challenges that could be resolved. A second recommendation is about updating regulation and guidelines. And of course, a lot of the transport infrastructure maintenance for the moment is based on regulations, sometimes national, international, and guidelines, and that are mostly based on the maintenance strategies that are corrective and that are predetermined. So that means that, for example, there's a maintenance strategy to have an inspection every 6 months, for example. And this could, in a way, could hamper the rollout of the deployment of data-driven approaches. So, in a way, some sort of a transformation would be needed to a more condition-based direction. And the final recommendation is about data governance and ensure that good practices are used when it is deployed for transport infrastructure maintenance. So that means privacy protection, of course. Data should be anonymized, encrypted. There should be non-disclosure agreements between the data providers and the infrastructure managers. Maybe there should be trusted third parties that could be used to collect the data to make sure that there's not going to be a private party that's going to use other data. And a safe answers approach, which basically means that only query results are exchanged and not the raw data. And finally, there could also be a role for governments in brokering data sharing partnerships and to make sure that they are actually used in the public interest. So 3 policy recommendations, and that brings the end to my presentation. Happy to answer any questions that you might have.
Thank you very much. Thank you, Olaf. Hugely interesting. A little longer than we usually have, but that's okay because it was really quite interesting stuff. Any questions that you have now, please type them into the Q&A, not into the chat, into the Q&A, so that I can collect them a little bit and pass them on to Olaf. I think there's plenty of stuff there. And if I may, I'll kick off with the first question that immediately came to my mind when you talked about rail and road. I'm sure those are not the only modes where data-driven maintenance is being tested and piloted. What about aviation, for example? I mean, it seems some obvious use cases there.
Yes, thank you for that question. Indeed, as a matter of time, I just talked about rail and road. In the report, we have several other sectors as well. Indeed, aviation and airports is one of them. I think you would say in aviation, there generally is an advanced use of these data-driven approaches. So that's of course related to the aircraft. All of the aircrafts have sensors. Well, you know this, and a lot of these sensors that generate information that are related to all kinds of things, vibration, the heat, the fuel consumption, etc. And all this, of course, can be used to get relevant information on what is the state of the plane and when would it need to be maintained. When it comes to airports, also there are interesting developments. There have been a lot of kind of standardized procedures in maintenance already since a long time, with all kinds of different indicators that have been used in several different airports. But we're seeing now also new technologies being used that can, for example, assess the emergence of deformities of runways, and can do all kinds of other things, temperature, strain, so that the let's say that these sensors can give more automatic impact and assessment of the degradation of runways. And this, for example, has been applied in airports as diverse as Shanghai or Hawaii, New York, when you have these sensors in the different runway pavements. Then the use of 3D laser scanning has also been used to detect the deformations on runways. So yes, aviation and airports are certainly also an interesting area for these kind of approaches.
I have a question here from an anonymous attendee who is interested in whether there'll be a second part of this report, of this project, that will focus on particular country cases. Maybe we can broaden this a little bit, and you can tell us where sort of the case studies, I imagine, looked at different pilot projects that exist, where did they happen, and where are differences maybe in approaches? You mentioned Shanghai, you mentioned Hawaii.
Yes, well, our perspective on this was not really on, let's say, on countries. It was more or less on different sectors. So simply to see what has been applied in the different industries, and that is what it tries to do. Indeed, some of the examples that we have here are as diverse as China, as Sweden. We have examples from Italy, from the US. On the basis of this, I think it would be difficult to say which countries are most advanced in this. I think it is certainly an interesting aspect to look at. For the moment, we haven't planned, I think, any follow-up on this particular work, but generally we have within the idea a lot of work on data-driven approaches to transport, and I'm sure there's more work that's going to follow on this.
Thanks. Another question comes from Elizabeth Villarauda, who asks about examples, practices, tools of data registers that are targeted to integrate climate change resilience for transport networks. So is sort of data-driven maintenance also maybe not the silver bullet, but something that can be extremely useful in the current drive to limit climate change and focus on data registers?
Yes, we haven't particularly looked at this, but of course this only makes I think the issue of data-driven approaches more relevant, because as there will be new situation and new contexts in a way, you also need tools to actually model that and probably also predict. And of course, in times of great uncertainty that are related to climate change, this is something that of course you would expect that can be of increased usefulness and relevance. So that is maybe a bit of a generic answer, but I think yes, there certainly is. There's a lot of developments that should take the climate change risks in different transport sectors into account.
Maybe let me follow up on that a little bit with a question about data sharing, because that seems to be very much at the heart of the issue. The applications that we see, which are kind of up and running now, are they operating on certain data sharing agreements, or is it mostly within organizations where data sharing maybe is not an issue, where they cover the whole spectrum of analyzing to then actually drawing conclusions from that and actually doing the maintenance?
Yes, I think a lot of the applications that we've seen, or let's say the examples that we have seen, are of course infrastructure managers that trying to do something with well, the data that they have, the new technologies that can generate these data. So that is one thing. But then, as I said, there's also other techniques that basically try to use data from someone else. So, for example, these pilots that try to use data from smartphones to say something about the state of certain roads. So obviously there you would need well, data sharing agreements, and also to make sure that these are agreements that well, that respect the good practices in data governance.
You mentioned that you were not so much looking at countries, but more at the different technologies and the use cases. But countries do play a big part when it comes to actually regulating all of this. And there's potentially a lot of regulation involved, because we're dealing with, as you said, mobile phones with sensitive data sometimes. Even non-mobile phone data can be sensitive if it ends up in the wrong hands. So how are different governments or entities that have sort of power to regulate this approaches? Is there an international standard? Are we seeing a patchwork of rules and frameworks evolving? What's the picture there?
I think this is mostly national regulations, but then there's also international standards and guidelines. But it indeed is an area that is the essence of the further deployment of these data-driven approaches. Because I think what you see a lot is that a lot of the regulation and the guidelines are still thinking about predetermined periods. So let's say after 6 months, there should be maintenance of this and this assets, and that is that's something that is still anchored in, let's say, the policies of well, a lot of countries. What that means is that for a company or an infrastructure manager that wants to deploy these data-driven approaches, maybe it doesn't really make sense to do an inspection every 6 months or the maintenance every 6 months. It just depends on the condition, and so it could happen that the infrastructure manager sees that after 6 months it's still in great condition, but that he actually should do something after 9 months. Then it's this moment isn't really possible, because the regulation actually obliges this manager to do something after 6 months. And that is also what I meant with the first and the second recommendation. That is, try to make sure that regulation is also can take this into account. Can be a little bit more flexible about this, because if you have still a regulation that is based on predetermined maintenance logic, it is going to be a bit too expensive to actually do both, because in that case you'll do the predetermined and you'll do the data-driven condition-based, and that's, I think, something that as these technologies develop will become more and more relevant for policymakers trying to adapt the regulations to that new reality.
We're kind of reaching the end of our allotted time. We can go a little bit over it. If there are more questions, so if you have one, type it in now, your last chance. And while you're doing that, let me ask Olaf something. I hope I don't put you on the spot, but what is your favorite example of data-driven maintenance? Is there something, was there a case where you said, this is really clever and this is something that should be done more, which is not evident, like putting a sensor into a bridge? Maybe something crowdsourced. You know, there was in Paris, there was a Twitter account where you could signal potholes that in other cities as well, which is slightly off track, but still interesting.
Yeah, no, there are several examples of that, trying to use smartphones to indeed to say something about the condition of the road. And of course, I think for the moment these are still pilots, so it isn't actually being used on a, let's say on a very wide scale. But these, I think, are of course the innovative approaches that you see now and that you will see more in the future.
Thank you very much. I haven't seen any question come in, so if you still have one, send us an email. We're very happy to continue this conversation outside of this very short kind of taster of our work on infrastructure and on maintenance. This video will be is recorded and will be online. So if you have colleagues who might be interested, do share the link. You will receive an email with the link ASAP. And I will launch a little poll. I need to go to my other screen and do that to hear from you whether you like this event, this kind of event or not, so we can do it more often or in a different format, or not so often. Thank you very much for your attention, for being here. Thank you to Olaf for taking us through the findings. Have a very good afternoon and enjoy the weekend. Thank you. Bye-bye.